This is Computer Architecture Group 6 of Computer Science. Today, we'll be diving into the world of CPU, talking about cache performance, cache directory, and LRU updates and replacement scheme. Please stay tuned.
My name is Kwame Amoateng Ennin. I'd like to talk about cache performance. In computer architecture, a cache is a small high-speed storage layer located between the main memory, which is the RAM, or the random access memory, and the central processing unit, which is the CPU. It is also a collection of items of the same types stored in a hidden place. The main purpose of a cache is to reduce the time it takes for the CPU to access data from the main memory by storing copies of frequently used data and instructions closer to the CPU. The cache minimizes latency and speeds up data retrieval. Cache performance. Cache performance is the rate of efficient data retrieval from the cache memory. Cache performance depends on cache hits and cache miss, which are the factors that create constraints to the system performance. Cache performance is equal to the number of cache hits over the total number of cache entries. Cache entries is the number of times the processor enters the cache, whilst cache miss is when the data is blocked from the CPU.
Hello, my name is Acquah, and I'll be talking about levels of cache memory. In the levels of cache memory, we have the level 1 cache, the level 2 cache, and the level 3 cache. The level 1 cache is the smallest but the fastest cache. It is also called the primary cache memory. The level 1 cache is embedded directly into the CPU, allowing it to operate at the same speed as the CPU. Is divided into the instruction cache and the data cache. The instruction cache collects instructions so that the CPU can execute those instructions, and the data cache collects images, text, and other files so that the cache can temporarily store it for the CPU. We also have the level 2 cache. The level 2 cache is more capacious than the level 1 cache. The level 2 cache is typically located on the CPU chip or very close to it. It serves as an intermediate between level 1 and level 2 cache, and it has a high speed bus connecting the cache to the CPU, hence avoiding traffic on the main system bus. The level 2 cache is also known as the secondary memory. We also have the level 3 cache. It is larger and slower, and it is shared among the cores of the multi-core processor. It acts as a last level cache before data is retrieved from the main memory. Level 2 cache is a specialized memory which helps improve level 1 and level 2 performance. So over here, when a CPU wants data, it goes to the level 1 cache because the level 1 cache is the smallest among all the 3 cache memories. When it doesn't get that data, then it moves to the level 2 cache. In the level 2 cache, it also looks for the same data, and when there is a cache miss, it goes to the level 3 cache, going to find the data it wants. If it doesn't find the data it wants, then it moves to the bigger memory, which is your SSD drive and your hard disk, going to find that memory. I would like to end here and allow my colleagues to add to what I've said.
Here are some cache mapping techniques that you should know. Direct map cache. Here, each block of memory maps to exactly one cache line. This is simple and fast, but it can lead to conflict. Fully associative cache. Here, any block of memory can be stored in any cache line. This is so effective because it does not lead to conflict. This is because it requires complex hardware for searching. Okay, third on the list is set associative cache. This is a compromise between fully associated cache and also direct map cache. The cache is divided into sets, and each block maps to a specific set. Next is replacement policies. When the cache is full, the replacement policies determine the data that should be evicted for the new data to be stored. Some of these policies include first in, first out. First in, first out. Okay, over here, the data that was accessed by the system first is what will be evicted for the new data to be stored. Then random replacement, and over here, this policy will select any data to be evicted. An example is I'm storing a data that is 10 megabytes in size. The system locates any file that is about 10 megabytes or more and evicts it for this new data to be stored.
So my name is Hassif Abbey, and I'll be continuing from where my fellow member ended his presentation. So I'll be talking about cache directories. Cache directories are data structures used in multiple cache systems to manage cache hierarchy and track cache line location. They help the CPU determine which cache level contains the desired data and provide information about the cache line's location in the cache hierarchy. Cache directories are essential for maintaining cache coherence, which ensures that all processors in the multi-processor system have access to the most up-to-date data. Cache directories typically consist of multiple levels, each corresponding to a different cache level in a cache hierarchy. Each cache directory level contains a set of cache tags, which are used to identify the cache line stored in that cache level. When a cache miss occurs, the computer checks the cache directory to determine the location of the desired cache line in the cache hierarchy. The cache directory provides information about the cache line's location, allowing the CPU to access the data more quickly. So the long and short of all this is that cache directories are nothing but data structures used by computer systems to store frequently accessed data such as files or web pages in a faster or more easily accessible location. In addition, cache directories are implemented using various data structures such as arrays, trees, or hash tables. The choice of data structure depends on factors such as cache size, cache associativity, and cache coherence protocol. Different cache coherence protocols such as MESI, that is Modified Exclusive Shared Invalid, or MOISI, that's Modified Own Exclusive Shared Invalid, have different requirements for cache directory management. To improve cache directory performance, several techniques can be employed, such as cache directory blocking, cache directory prefetching, and cache directory replacement policies. Cache directory blocking involves dividing large data arrays into smaller blocks and storing them in the cache directory.
I'll be continuing from where my friends left off. Cache directory prefetching simply means getting data or information from a cache before the system actually needs it. We have two types of cache directory prefetching. One is the data prefetching and instructions prefetching. Data prefetching simply means getting data from a cache before it's actually needed by the system, while instructions prefetching involves getting instructions from the cache before it is actually executed by the computer. So this is the summary of what cache directory prefetching simply involves. So let's move on to the next one. To summarize everything, or to put everything under one umbrella, the cache directories are data structures used in multi-level cache systems to manage cache hierarchy and track cache line locations, as explained by my friends earlier on. Cache directories are essential for maintaining cache coherence and ensuring that all processes have access to the most up-to-date data. Cache coherence simply means when an information on a cache line is changed in a multiprocessor, it has to run through all the other multiprocessors connected to it. That's simply just it. And cache directories are implemented using various data structures and can be improved using techniques such as cache directory blocking, cache directory prefetching, and cache directory replacement policies. Cache directory blocking simply means dividing large data arrays into blocks and storing them in a directory. And cache directory prefetching, earlier on as I said, is just a process of getting information from the cache before it's actually needed by the computer. Cache directory replacement policies are policies that helps to minimize cache misses and also improve overall system management, such as the LRU, which will be explained by my friend in the next video. Thank you.
I'm Munir Naadirah Bint, a member of Group 6. I'm going to talk about a preview of least recently used update, LRU. LRU, least recently used, is a cache replacement policy that replaces the cache line that has not been accessed for the longest time. It is a popular cache replacement scheme due to its simplicity and effectiveness. LRU works by maintaining a list of cache lines in the order they were last accessed. When the cache becomes full and a new cache line needs to be stored, the oldest cache line in the list is replaced with the new cache line. This ensures that the cache contains the most effective access data. LRU has several advantages, including simplicity, low overhead, and good performances. It is easy to implement and requires minimal additional hardware support. Additionally, LRU has been shown to provide good cache performance as it tends to evict less frequently accessed cache lines and retain more frequently accessed cache lines. However, LRU has some limitations. It may not perform well in scenarios where the access pattern is highly variable or unpredictable. In such cases, other cache replacement policies such as LRU with adaptive replacement, which is LRU-AR, may be more effective. LRU-AR is an extension of the LRU policy that adapts the replacement scheme based on the observed access pattern. It uses a combination of LRU and random replacement to improve cache performance in scenarios with variable or unpredictable access patterns. LRU-AR has been shown to provide better cache performance compared to the traditional LRU in such scenarios. In summary, LRU is a cache replacement policy that replaces the cache line that has not been accessed for the longest time. It is a simple and effective cache replacement scheme that provides good cache performance in many scenarios. However, LRU may not perform well with highly variable or unpredictable access patterns, in which case LRU-AR may be more suitable cache replacement.
dive into this wonderful experience. I hope you enjoyed this video. Thanks for watching.